Right, I try to make these videos as short as possible, but I didn't check the memo, so that's why I might take a little bit longer. So I'm doing the special cases, the difficult questions. These questions are the kind of questions that you'll find at the end. They are your typical 1.3, 1.4 type of questions, and you need to master them so that whenever you step into an exam, you know that anything that is going to be in question one, you will get marks for it, right? And if you do this, there's nothing stopping you from getting your 100%. Remember, with mathematics, it all starts and ends with algebra. That's all there is to it. Forget those big, scary shapes, analytical geometry, and everything else. It all starts and ends with this algebra. So let's start with the first question. I didn't check the memo, so I might take a little bit longer and I'll verify my answers. But I don't think I'm gonna make a mistake, right? So let's call this question one. We have m is equal to 2 to the power 0.2 and m is equal to m to the power b is equal to 16, and they say determine the value of b. That's what they're saying, determine the value of b, right? Okay, so whenever you come across, oh my god, this camera is fucking blurry. Listen, sorry. Whenever you come across these questions and they give you two expressions and they say determine some value, right? We have the first expression which says m is equal to this and m to the power b is equal to this. Try to break, the first thing you should do, break down these expressions a little bit further and try to relate them. You're doing two things, you're breaking them down and then you're trying to relate them. They are related somehow, right? Try to prove they're related. Once you prove they're related, you can solve them. Every time, that's the trick. I'm telling you, there was this question last year in the final exams and also in March. You try to relate them. That's what you try to do. Relate these expressions. So we look at m is equal to 2 to the power 0.2. There's nothing we can do here. We cannot break it down a little bit further. Remember I said break it down and see where it's gonna go. And usually when you do that, it becomes similar to the other one, and then you can relate them and solve the equation. But we have m to the power b is equal to 16, right? Remember, in mathematics and algebra, we break down big numbers using exponents into smaller numbers raised to powers. That's what we do, right? So let's take m to the power b, which is equal to 16. There are two ways you can break 16. You could have 16, which is equal to 2 to the power 4, or 16 is equal to 4 to the power 2. If we use the calculator, it's going to give you 4 to the power 2. But you have to be smart about this, right? You want something that is going to relate to that equation. Remember, whenever you're dealing with a question like this, you're trying to relate things. You're relating things. That's what you do, my brother. Okay, bruv. We have m to the power b is equal to 2 to the power 4. Right. Surprise. M to the power b is equal to 2 to the power 4. That is amazing. Right. So we are there right now and we're trying to solve for b. Right. But m is equal to 2 exponent 0.2. Right. Therefore, right. Right, but m is equal to 2 exponent 0.2. So we can, here's what we can do here, right? We can go back to this equation. Let's call it equation 1 and this equation 2. We can go back to equation 1 where m to the power b is equal to 2 to the power 4. And then I hope you can see we multiply, right, by 1/4 on both. Remember, what you do on the other side, you do on the other side as well. So we'll have that. Oh, excuse me, sorry. I was trying to go for this. So we have m to the power b is equal to 2 to the power 4, right? Here's what we can do here. We can say m to the power b times 1/b is equal to 2 to the power 4 times 1/b. We're doing this because we're trying to get rid of the exponent, which is b, right? So you will have m, because trust me, this is right here, the exponent, this is b over 1 somehow times 1/b, and then they cancel out, and then you're left with 1. So m to the power 1, we don't have to write the 1, is equal to 2 to the power 4 over b, right? And then voila, they're the same. Remember, we're trying to relate the two things, right? So m is equal to this and m is equal to this. So we can say m is equal to 2 to the power 4 over b, which is equal to 2, 0.2, just like that. Proved. And then so we're going to say 2 to the power 4b is equal to 2, 0.2. Their bases are the same, right? So we can bring down the exponents. So we'll have 4 to the power b is equal to 0.2, and then well, we multiply by 1/4, multiply by 1/4, then we have 1/b, which is equal to, let me use the calculator. Blurry, right? I told you it's gonna take forever because I didn't look at the memo. So 1/4 times 0.2, we have 1/20. So 1/b is equal to 1/20. You cross multiply, so cross multiply, b times 1 is b, 1 times 20, it's 20. So b is equal to 20. You have your answer right there, right? I know it's taking forever because I didn't check the memo. I'm trying to show you the logical process here. I'm trying to show you what we go through when we answer these kind of questions. Right, given m is equal to x multiplied by x minus y squared. Blurry. I don't know why it's blurry like that. Now it's fine. I guess when it moves, it becomes blurry. So they say determine the value of m if xy squared is equal to 4 and x to the power 3 minus 2x squared y is equal to 3. Right, I hope you can see the equation. Well, the equations, because I think there are 3 of them, and we'll try to relate them. Remember what I said the last time we're doing a question like this? You relate stuff. You look at the equations, I swear they're identical somehow. You break them down, you'll see that they're identical, so you try to relate them. Okay, so this is going to take longer because I didn't look at the memo. I'm going to keep saying that, my brother. So we have that m is equal to that, and that is equal to that. We look at what we can do right here. Okay, so picture this. You are in the exam room. You don't know what the fuck is going on. You're stressed and you see this kind of question. It doesn't make sense. The first thing that you do is break down these equations and see if they can relate to each other. So this is what I'm doing. We have x to the power 3 minus 2x squared y, which is equal to 3, right? What is common here? X is very common, right? So we can, x squared is common, because if we take x squared out, that is what is common. X squared is common, not x. Yes, x is common, but the most common thing, the highest common factor, that's why we say the highest common factor, bruv. So the highest common factor is x squared. We're looking for the highest common factor. Let me write it down. Highest common factor, oopsie, is fuck, it's HCF, right? Highest common factor. Fuck. So we take x squared out, and then we're left with x minus 2y is equal to 3. Right. That's what we have. And yes, in this case, it's not going to help us to do that. So I scratch it out. I'm just experimenting. We want something that is going to relate to that. We want to relate stuff, right? So taking out x, not the highest common factor in this case, we're going to take out x, and then we'll be left with x squared, right? Minus 2x or when you take out 2xy. Okay. Right. So it doesn't seem like it's gonna work out, right? Me factorizing anything, so I scratch it out. These two equations, x cubed minus 2xy squared plus y is equal to 3, and xy squared is equal to 4, doesn't look like they're related, right? So let's try to break that one down. So we have m, which is equal to x minus y squared. So m is equal to x, right? Let's put it out there. Square brackets. These square brackets don't mean anything, by the way, in this case. I'm just using them so that I can differentiate these two equations, because they're not the same thing. Well, actually ignore all of that, but understand that these square brackets don't mean anything. They only mean something when I'm using inequalities, right? Excuse me. So we have x minus y. We're expanding this, right? Then we expand it like the square brackets. I'm using these square brackets to separate. That's all. They don't mean anything, but square brackets mean included. But in this case, I'm just using them so that my work can be neat, not messy. So we deal with what's inside. So x times x, that is x squared. X times negative y is negative xy. Negative y times x is negative xy still, plus y squared, like that. Then m is equal to x. And then you have x squared minus 2xy, like terms, plus y squared. And then you distribute the x. You will have your x to the power 3. Don't get scared. Don't get scared when it's becoming like this, right? I'm making it simple. Don't get scared. I know you've never seen a cubic equation before. X to the power 3 is a cubic equation. So we have x to the power 3 negative negative 2x negative 2x squared, right? The x multiplies there. The x multiplies the x squared, and it multiplies everything right there, everything. We have negative 2x squared y plus x y squared, right? Remember I said relate, try to relate things, relate them. So you look there, we have xy squared is equal to 4, and x cubed minus 2x squared y is equal to 3. Right, let's relate. What do we have here? We have x squared minus 2x squared y. That is equal to 3, right? They were relating. Sorry. It's equal to 3 right there. It's equal to 3 right there. So we put 3 plus. We also relate xy squared is equal to 4, right? So we add the 4. So basically, your m is equal to 7. Like I said again, if you can see these questions properly, you can look in your app. I'm just explaining them. It's in the grade 10 app. You can find them right there. I hope you can see. So m is equal to 7. So let's do the last one for today. I'm taking forever because I'm taking 20 minutes, 16 minutes because I didn't look at the memo, right? So I'm just doing this. So we have if 6 to the power 7 is equal to x, determine the value of 6 to the power 2 multiplied by 5 to the power 3 multiplied by 4 to the power 4 multiplied by 3 to the power 5 in terms of x without a calculator. Bear in mind, remember this, when they say in terms of x, they mean they mean leave your answer with x, do not solve the x. In terms of x means your answer should have x attached to it, right? So it's the same question. You try to relate things. We're trying to relate. We break things down and try to relate them every time you're dealing with these questions. Break things down and try to relate them. So we have 6 to the power x is equal to 6 to the power 7 is equal to x. Excuse me. Sometimes it feels as if I can see this and I said the wrong things, but I'm writing the right stuff. So we want to match this to this. Do you see it? Right. So let's break things down. Let's go with the long equation first. Right. Well, let me see the value of 6 to the power x in the calculator. 6 to the power x. Oh, that is 2,000 and something. That is 279,000 and something. It's a huge number. We don't care. So, right. This is multiplication. So here's what we can do here. We have 3 and 3, right? Right. So let's break down this and this. So 6 to the power 7 equal to x is the same thing as 3. Sorry. Now you can see it. This is 6 to the power 7, which is equal to x. Fuck. No, I've been talking way too much. I almost said sex. It's crazy. So 3 times 2 to the power 7 is equal to x It's the same thing, right? I broke down 6 because do you remember when I showed you that you can break down the big numbers? 6 doesn't have any exponent, right? So you can break it down to 3 times 2. The same goes for 10. You can break it down to 5 times 2, right? So that's what we did. So we have 3 times the power 7 equal to x, right? We stop there. There's nothing we can do. We go to this equation, which is 6 to the power 2 times 5 to the power 3 times 4 to the power 4 times 3 to the power 5, right? Let's break down the let's do the same thing even here, right? So we break it down. We have 3 times 2 to the power 2 times 5 to the power 3 times 4 to the power 4 times 3 to the power 5. Right, so here's what we're going to do. We will, okay, that's what we have, right? So we broke down the 6, right? So it's 3 to the power 2 times 2 to the power 2 times 5 to the power 3 times 4 to the power 4 times 3 to the power 5. Remember exponent laws, right? This 3 to the power 2 is also multiplying that 3 to the power 5. Everything here is multiplying everything. So you can arrange this into this form: 3 to the power 2 times, right, 3 to the power 5. You can arrange it in whatever form you want because it's all multiplication. This is only not allowed when there's a minus sign, but it's multiplication. It doesn't matter where you put each number. You can put this number over here, you can put this number over here, you can put this number over there. So excuse me, sorry for that. I can't see properly. Sorry for that. Right, so we have 3 to the power 2 times 3 to the power 5. Remember exponent laws, right? Let me go here and show you, right? A to the power n times a to the power m is equal to a n m. Exponent laws, you remember that law, right? So this 3 to the power 2 times 3 to the power 4 is the same as 3 to the power 7, right? It's 2 plus 5, the 7. Oh, excuse me, I forgot something. You add, is n plus m. It's called a to the power is n plus m. That's you add, right? So it's 2 plus 5 is 7. And so you have 7, and then you let's break down the 4 to the power 4. You have 2 to the power 2, and then we come here, the 4 to the power 4. We break it down times 2. 4 is 2 to the power 4, right? We know that 4 is equal to 2 to the power 2. I'm sorry, right? So 2 to the power 2 times 4, that's 8. So we have 2 to the power 8. 2 to the power 8, where does it come from? You break down 4, you have 2 to the power 2. That 2 will multiply the 4. We'll have 2 to the power 8. Exponent laws, remember. 2 to the power a times to the power b, like that, is the same thing as 2 to the power ab, right? Exponent laws. So we have 2 to the power 8 times what is this? 5 to the power 3. So that is what we have. Let me say equal to, equal to, equal to, equal to, right? That is what we have, right? And we want something like this. We want that 3 times 2 to the power 7 is equal to x. Then we come here, right? You see that here's what we're going to do. We have 2 to the power 2, right? We're going to use the exponent laws. This exponent law, a to the power n times a to the power m is equal to a n plus m, right? So we add this. So we're going to have is equal to 3 to the power 7 times 2 to the power 10 times 5 to the power 3. So here's what we're going to do. We want this to be 2 to the power 7 so that we can get something like this. We want this, which is equal to x, so that the answer could be in terms of x, right? So we're going to say 3 to the power 7 times 2 to the power 7 times 2 to the power 3. Where does the 2 to the power 3 come from? Remember exponent laws. 2 to the power 7 times 2 to the power 3 is equal to 2 to the power 10, right? Exponent laws, you add the exponents, and when you're multiplying bases that are the same. Do you understand this part, right? So I broke the 2 to the power 10 so that I can get this, right? Remember, it's all about relating. We took this 6 to the power 7 is equal to x and broke it down to x and broke it down here so that we can relate it to this, right? 2 to the power 3 times 5 to the power 3. So this is going to be equal to, we take this 3 times 2 to the power 7 to the power 3, 5 to the power 3, right? Remember, 3 times 2 to the power 7 is the same thing as 3 to the power 7 times 2 to the power 7, right? So we're going to have, this is x. Why am I saying this? This is x. This entire thing, this is equal to x. So x is equal to 2 to the power 3 times 5 to the power 3. We can punch, and then you punch this into the calculator. So we have 2 to the power 3, which is 8 times 5 to the power 3. The answer is 1000. So x is 1000. So you have your answer. There it is, right? So the trick in these 3 questions is to relate. Don't be scared. Pick the first equation, break it down, and see if you can relate it to another. After breaking it down, you move on, you break another one down. Do this until they relate, right? I didn't take the memo because I wanted to show you the kind of thinking, the kind of logic that we go through when we answer these questions. I didn't want to check the memo and understand how and make it easy, right? I didn't do that. I want you to understand that you try out every equation. That's the real struggle. So you can check these questions in the app. I got them from March and the exemplars.